Hello, dear Mathbaras. How are you today? Hope you are doing fine and okay. Welcome to my YouTube channel and thank you for watching my content. And for today's discussion, we will learn on how to simplify radical expression. But before I start, make sure you hit the subscribe button and the notification bell to be updated with my latest content. And I will be more glad if you will like this video, leave a comment, and share with friends. Follow me and like my Facebook page, Math Sherwin Math Tutorial, for more math lesson. So let's begin this math lesson now. Hello, dear Math Bares. My name is Sir Sherwin, and I will be your math instructor. For today's discussion, we will learn on how to simplify radical expression. The question is, how will we know that the given expression is already simplified? These are the things we need to remember. First, make sure that the index is greater than the exponent of our radicand. Second, there is no factor in our radicand wherein its exponential form is equal or greater than the index. And third, there will be no radical symbol in the denominator. So these three ideas will really help us identify that the given radical expression is simplified. Before we start simplifying, let us also remember the different laws of radicals. What are these laws? First on the list, if our index and the exponent of the radicand is the same, it follows that we can cancel this out. And the answer is the radicand itself. Again, if the index and the exponent of our radicand is the same, we can cancel it out, leaving our radicand itself as the simplified form. The second one, the product of our certain radicand is equal to its factors. That means if we multiply nth root of a and nth root of b, the product would be the nth root of ab. This is considered as the product rule of our radical expression. Third, if we have the nth root of a over b, it is equivalent to the nth root of a over the nth root of b. And this is known as the quotient rule of our radical expression. So these three laws of radicals will be very essential as we simplify a radical expression. With this, let us try to have our first example. Let's have our first example. We have square root of 9. Here, in this radical expression, our index is 2. It is understood even that it is not written here, our index is 2 because the lowest possible index would be 2. On the other hand, 9 represents our radicand and it has an exponent of 1. But remember, 9 is a perfect square and 9 can be written in exponential form as 3 squared. So this means we can simplify this expression as square root of 3 squared for the reason that 9 can be written in exponential form and that is 3 squared. In this case, we can apply the first law wherein our index and exponent of the radicand is the same. So if our index and exponent of the radicand is the same, we can cancel it out, leaving the radicand as our final answer. This means square root of 9 is equal to 3. So this is how to simplify our radical expression. Let's have our second example. Our second example is cube root of 8. In this given radical expression, our index is 3. And 8 as a radicand has an exponent of 1. But bear in our mind also that 8 is a perfect cube. And if it is a perfect cube, we can write it in exponential form. In this case, 8 can be written as 2 cubed. This means 8 is a result when we multiply 2 by itself 3 times. That means 2 times 2 times 2, the result would be 8. And in this case, we can again apply the first law of radical, which is the index and the exponent of our radicand, which is the same. So we can cancel it out. So our answer here is 2. So cube root of 8 is equal to 2. Let's have the third one. We have fourth root of 81. From this certain expression, our index is 4 and our radicand is 81, where it has its exponent of 1. But again, bear in our mind that 81 can be considered as a perfect number. It can be a perfect square, and at the same time, it can be a perfect fourth power. Because 81 can be written in exponential form as 3 to the fourth power. This means we will multiply 3 by itself 4 times, and the result would be 81. So fourth root of 81 can be written as fourth root of 3 to the fourth power. Again, we can apply the first law of radical, wherein if the index and the exponent of our radicand is the same, we can cancel it out. So in this case, the simplified form of fourth root of 81 is 3. So bear in our mind the first law of our radical. If our index and exponent of the radicand is the same, then we can cancel it out, leaving the radicand itself as our final answer. Let's have the fourth one. We have square root of 72. In this case, our index here is 2 and our radicand is 72. But the radicand has an exponent of 1. If we are trying to look at it, it is already simplified. But bear in our mind the second law of our radical. If our given radicand has a factor wherein one factor can be written in its exponential form which is equal or greater than our index, then we can simplify it. In this case, 72 is not a perfect square. But of course, we can still identify the possible factors of 72. Since our index is 2, we will think of a factor of 72 where 1 is a perfect square and the other is a non-perfect square. In this case, 72 may have a factor of 36 and 2, because multiplying 36 and 2, the product would be 72. So we can have the possible factors of square root of 72 as square root of 36 times 2. So this is an example of a product rule of our radical. So we can have this one as square root of 36 times square root of 2. Since 36 is a perfect square, we can write this one in exponential form, and that is 6 squared. On the other hand, 2 is not a perfect square and it is already written in simplified form, so we will simply copy square root of 2. Applying the first law of our radical, wherein our index and exponent of the radicand is the same, then we can cancel this out. Our final answer would be 6 square root of 2. So therefore, our answer as we simplify square root of 72 would be 6 square root of 2. Let's simplify the fifth example. We have square root of 200x cubed. This is again applying the second law of our radical, which is the product rule. From this certain expression, 200 is not a perfect square, same as true with x to the third power. But 200 and x cubed may have factor where one is a perfect square and the other is a non-perfect square. So in this case, 200 may have a possible factor of 102. Why I choose 100? So in this case, 100 is a perfect square and 2 is a non-perfect square. On the other hand, possible factors of x cubed would be x squared times x. In this case, we are simply applying the product of the power in the laws of exponent, wherein we just simply add the exponent of our given variable as we multiply them. So how will we simplify now this given radical expression? So here, we will write the exponential form of 100, and that is 10 squared. Then copy square root of 2 times square root of x squared times square root of x. Again, applying the first law of our radical, wherein the index and the exponent is the same, we can cancel it out. In this case, square root of 10 squared, we have the same index and exponent, so leaving 10 here. Then we will simply copy square root of 2. Likewise, we will eliminate the radical symbol and the exponent here for the reason that our index and exponent is the same. So we'll have variable x and copy square root of x. So in this case, we can multiply our coefficients referring to 10 and x. So 10 times x, that would be 10x. And have in the radicand form would be 2 and x. So we'll simply copy 2 and x. So this would be the simplified form of square root of 200x cubed. And that would be 10x square root of 2x. Let's have the sixth one. So we have square root of 32y to the fourth power. So how will we simplify this given expression? Again, applying the second law of our radical, which is the product rule, we will think of a possible factor of 32, where one is a perfect square and the other is a non-perfect square. Looking back to the possible factors of 32, so it will end up in our mind that that would be 16 times 2, where 16 is a perfect square and 2 is a non-perfect square. So we will choose the possible factors of 32, and that is 16 times 2. While y to the fourth can be written in its exponential form as quantity of y squared raised to the second power, and that is applying the power of powers, wherein we are multiplying the exponent outside our grouping symbol to the exponent inside our grouping symbol. So let's now simplify this radical expression. So 16 can be written in its exponential form, and that would be 4 squared. While we will just simply copy square root of 2. And again, copy quantity y squared raised to the second power. So we can eliminate our radical symbol since our index and exponent is the same. So we'll have 4. Then copy square root of 2 times this one. So we can eliminate also our radical symbol since our index and exponent is the same. So that would be y squared. So we will group the terms that is outside our radical symbol and group the terms that is present inside our radical symbol. In this case, 4 and y squared will be considered as our coefficients, both numerical and literal coefficients. So we'll have this one before our radical symbol. So we will have 4y squared square root of 2. So this would be the simplified form of our given radical expression, square root of 32y to the fourth power. Let's have the seventh one. We have square root of 3 halves. And this certain expression, we can simplify this one using the third law of our radical, which is the quotient rule. Since we have square root of 3 halves, this expression can be written as square root of 3 all over square root of 2. But earlier we mentioned that a radical is considered to be simplified if and only if there is no radical symbol in the denominator. Remember that the process of eliminating our radical symbol in the denominator is known as rationalization. Again, it is rationalization, wherein we eliminate radical symbol in the denominator. So how will we rationalize or simplify this given radical expression? So all we need to do is to think of a possible number that will be multiplied to our denominator to make it as a perfect square. And I would suggest it would be better to multiply this one by itself. So this means we will multiply both by square root of 2 all over square root of 2. Remember, square root of 2 over square root of 2, that is equal to 1. and applying the mathematical concept wherein if we multiply a number by 1, the result will still be a number. So for us to simplify this, all we need to do now is to multiply both numerator and numerator. That would be square root of 3 times square root of 2. Again, in multiplying our radicals, we just simply multiply the radicand if and only if our index is the same. So we will just simply multiply our radicand here because we have the same index, and that is 2. So that is 3 times 2. That would be 6. While square root of 2 times square root of 2 can be equal to square root of 4. And it would be the same as 2 squared as its exponential form. So we will have square root of 2 times square root of 2, that is 2 squared. Why did I multiply this by square root of 2? In order for us to make this one a perfect square. And because it is a perfect square, applying the first law of our radical wherein the index and the exponent of the radical is the same, we can cancel it out. So therefore, we will have square root of 6 all over 2 as our answer. Maybe you are asking, sir, can we simplify 6 over 2 to make it as 3 or square root of 3? Here, the answer would be, it cannot be simplified that way. For the reason that 6 is considered as our radicand or an expression inside our radical symbol. So we cannot eliminate or we cannot simplify a number that is inside our radical symbol to a numerical coefficient. So we will have this one as our final answer. So square root of 3 halves can be written in its simplest form as square root of 6 all over 2. Let's have the 8th one. We have square root of 3/5. So how will we simplify this radical expression? So again, this is an example of the quotient rule, wherein square root of 3/5 is equal to square root of 3 all over square root of 5. This is not yet written in its simplest form for the reason that we have a radical symbol in the denominator. And for us to eliminate this one, the process is known as rationalization. So how will we rationalize? It is for us to think of a number that can be multiplied to 5 to make it a perfect square. And again, one of the suggestions I had earlier is that we will simply multiply it by itself. This means we will multiply this given radical expression by square root of 5. So we have square root of 5 times square root of 5 and square root of 3 times square root of 5. So here, we will simply multiply numerator times numerator. Again, radicand by radicand. So we will have square root of 3 times square root of 5. That would be square root of 15. And our denominator would be square root of the quantity 5 squared. Since we are multiplying 5 by itself, that is equivalent to 5 squared. In this case, we can eliminate our radical symbol since our index and exponent is the same. So we will have all over 5. So this would be the simplified form. In my next tutorial, I will be providing additional examples with respect to simplifying radical expression. There you have it. Hope you learned something new today. God bless us all.